Good evening, doctor. Good evening, everyone. This is my research proposal presentation. My topic is optimization of wireless network performance, protocol design for energy efficiency and secure communication in 5G, LTE, long-term evolution, and wireless sensor networks, the WSMs. My name is Francis Xavier Vaughan, and I'll start with the introduction. So, why are we doing the study? So, because of the wireless communications rapidly evolving with advanced technologies like 5G, LTE, and wireless sensor networks, driving high speed, low latency, and reliable connectivity through in smart cities, industrial automation, and environmental monitoring is becoming more essential than it used to be. So, because of that growth, the increased energy consumption is posing challenges in resource constrained areas like villages, places where power is low, and this heightens and heightens in cybersecurity risks. For example, some of the security threats, for example, hacks, phishes, and others in complex environments in the interconnected nature of the modern networks. So, in regions like Uganda, where telecommunication companies often face financial and infrastructure constraints, there is a critical need for an integrated protocol that actually simultaneously optimizes energy efficiency and enhances the security to ensure sustainable and resilient network performance. So we need to develop a protocol that actually enhances the security as well as actually being uh, sustainable. So what is the problem? What is the problem? So we are found out that there are existing protocols, but these protocols only cater for either energy efficiency or security, but not both. So this results into suboptimal performance, higher operational costs, and vulnerability to cyber threats. And when you look at some of the specific challenges, for example, the energy consumption, you find that in network densification and rising sorry, data demand accelerate battery depletion, and this increases operation expenses and environmental impact. And when you look at the side of security vulnerabilities, because of the inadequate security protocols, networks are exposed to breaches and disruptions. And in our Ugandan context, you may find that telecommunication companies face additional challenges due to limited financial and technological resources. Urgent there's urgent need for an integrated solution that actually addresses both energy and security concerns simultaneously. So when you look at some of the aims of the study, the aim of the study is to design, implement, and validate an integrated wireless network protocol that optimizes both energy consumption and security for 5G, LTE, and wireless sensor networks in Uganda. Some of the specific objectives include to access the current performance of existing protocols using simulations and field data. The second one is to develop a novel cross-layer integrated protocol incorporating adaptive routing strategies, lightweight cryptographic techniques, and machine learning-based dynamic tuning. Another one is to develop the protocol on controlled test beds and through case studies with at least 3 Ugandan telecom companies, and to compare the performance uh, using energy use, later throughput, security resilience against current standards. So how do current standards compete with the new protocol that's going to be developed? When you look at the security questions, uh, what are the questions we're going to base on actually develop this protocol? One of the questions is what are the primary energy efficiency and security challenges faced by Uganda Telecom companies. So we are look at what are some of these challenges faced by Uganda Telecom companies, and how can this cross-layer design and machine learning be integrated to optimize both energy consumption and security in the new protocol. How does the performance of the proposed integrated protocol compare with existing protocols in the real world deployments. And the hypothesis we are going to use is one is no significant difference exists in energy consumption and security between the proposed protocol and the current protocols. The second one is the integrated protocol significantly reduces energy consumption and enhances security compared to existing protocols. So the scope of the study is going to be the geographical scope. We shall focus on telecom companies across Uganda. Then the content scope we are going to focus on analyzing design and simulation and experimental validation of the post layer integrated protocol. The time length is going to be a 12-month study divided into data collection, implementation, and evaluation. And according to the methodological scope, we shall use methods, and we shall look at that one more. So the significance of the study. Why are we carrying out this study? Because it's going to fill gaps by integrating energy efficiency with robust security measures. And because of that, it will advance theoretical frameworks in cross-layer design and adaptive product development. So some of the practical implications for telecom companies, it will reduce energy consumption leading to lower operating costs, and it also enhance network security through service reliability and customer trust. When you look at industrial standards, it will provide insights that would influence the future protocol design and operational guidelines. And what's the wider impact? It will promote environmentally sustainable practices and it will support economic viability in resource limited settings. The method we are going to use is a mixed method approach combining descriptive analysis and experimental research. So we are going to collect data using simulation through tools such as NS3, Omnet++ to capture performance metrics, and we shall go to the field to collect data from participating Ugandan companies that we shall write to. Then we shall collect using qualitative methods. We shall do interviews and surveys with network engineers and managers, and then we shall do document analysis through reading reports and existing research. So we shall do analysis on the data using the statistical analysis of simulation and the field data. Then the qualitative, we shall look at thematic analysis of the interviews and survey responses. Then we shall include machine learning employed to protocol parameters based on historical and real-time data. So the expected results, we the expected outcomes will lead. One of them is reduction in energy consumption by at least 20%. Then enhanced security performance compared to the current protocols. Then some of the key performance metrics like we looked at: the energy usage, latency, throughput, packet delivery ratio, and the frequency of the security incidents. Then the contributions, we are going to create a new protocol that's going to be integrated, and the crossover protocol that addresses both energy efficiency and security challenges. There's going to be an innovative approach through the utilization of adaptive routing and lightweight cryptographic techniques enhanced by machine learning. So the practical framework is going to be a scalable and deployable model for Ugandan telecom companies and similar environments. So the broader impact is going to be providing a potential influence on the future research and industry-based practices in wireless network optimizations. Some of the limitations we are looking at, or the challenges, is that accessibility, because there is a potential difficulty in obtaining comprehensive field data from telecom companies. So we anticipate if there's difficulty, then that would be a challenge. Then we have resource constraints, the availability of funds actually to procure some of the test beds, hardware, and simulation tools. Then if we generalize, we look at the findings may be specific to only Ugandan companies. So bringing them in to put them in the worldwide ratio, it may not be good. Then we have the time constraints because we're going to we're going to carry out the study in 1 year. So the mitigation strategies combining simulation with field data to enhance reliability, relative tracing, and feedback loops to define protocol design. So the time frame is going to be 12 months. We carried out in 12 months. Our budget is going to be 6 million, and the budget will ensure adequate support for research personnel, technology requirements, and data acquisition efforts, along with provisions for dissemination of results. Then I conclude by saying that this is a comprehensive research proposal focus on developing an integrated wireless network protocol, addressing the dual challenges for energy efficiency and security in 5G LTE. So its impact is expected to be significantly improve network performance, reduce operational costs, and enhance security measures in the Ugandan telecommunication networks. The study has a possibility of extending the research to access long-term scalability through its adoption for broader regional and global applications. So this study lays a solid foundation for advancing sustainable and secure wireless communication technologies in resource-constrained environments. Thank you so much, Doctor. India.